So in this video, we are going to be talking about the most basic chemistry, starting out with atoms and talking about atomic structure. And so you may be wondering, why do I need to know this for A&P? Here's why you need to know this for A&P. Everything in our body is made up of atoms. There's a lot of chemistry that's going on in the human body, and you're going to need to have kind of a basic overall understanding of it in order to do well in A&P. It's going to keep coming up over and over in the entire A&P series. So what I want to do is kind of start from the ground level, assuming that you have no chemistry background whatsoever, and talk about what atoms are, so kind of define them, and then also teach you about what's known as the Bohr model. So the Bohr model is a model that scientists have come up with that kind of represents what an atom would actually look like. So my definition of an atom is it's the smallest unit of matter. Everything in the world, everything in our bodies is made up of atoms. One of the elements out there that many of you are probably familiar with, maybe you have some jewelry made out of it, is gold. And so if we were to talk about the smallest unit of gold, the smallest unit of gold is an atom of gold. If you look over here, I've got what's known as a Bohr model drawn, and this is just, again, a scientist's way of representing what an atom actually looks like. These are teeny tiny, not observable, even with the most powerful microscopes that we have, and so we don't have pictures of them, but we do have these representations that scientists have come up with. So what I've drawn here is an atom of an element known as lithium. And if you're familiar with the periodic table, you know that it's composed of all of these little blocks that represent all of the known atoms. So here's what the block of lithium would look like from the periodic table. And there's a few things that as an A&P student, you need to know about these atoms. So the first of these is the periodic table gives the name, so this is lithium. But all of these atoms that are out there, all of these elements that are made up of atoms have chemical symbols. So the chemical symbol for lithium is Li, and that's often how you'll see it represented. There are some elements that are important to anatomy and physiology. One of the things that we get from this block from the periodic table, another one of the things, is we get what's known as the atomic number. So the atomic number is always given in the upper corner. Sometimes it's the upper right, sometimes it's the upper left. It just kind of varies from periodic table to periodic table. But this is a super important number, something that you want to know, that you want to have an understanding of what it represents for anatomy and physiology. So you can see here that the atomic number for lithium is 3. And the atomic number basically is the number of protons in the nucleus of the atom. So if you're really just starting out with kind of basic chemistry, no background yet, you're probably also wondering, okay, what's the nucleus? What are protons? So that's what I want to go into next, using our Bohr model to kind of describe that to you. So here's a representation of lithium. Right here, we have this dense central core of this atom, which is known as the nucleus. Okay, so that's the nucleus that I referred to. And I mentioned previously that inside of the nucleus, we have these particles, which are known as protons. So there's a few things that you should know about protons. First of all, they're always found in the nucleus, so in that center part of an atom. And secondly, they are positively charged. So going back to that atomic number of 3, what we see with an atom of lithium is that there are 1, 2, 3 protons within the nucleus, and each one of those protons has a positive charge to it. Also found in the nucleus of atoms, we have what are known as neutrons. So they're in the nucleus, they don't have a charge to them, they're neutral, and we don't really worry about them so much in anatomy and physiology. And for that reason, I don't really typically draw them into my drawings. If you take chemistry classes, you'll definitely be more worried about those. But for the sake of A&P, we don't get into neutrons so much. But you should know that when they're present, they're in the nucleus and they're neutral. They don't have a charge. So the last subatomic particle, or teeny tiny particle that's there with the protons and neutrons working to make up an atom, is what's known as an electron. So electrons are not found in the nucleus. That's one thing that you should know about them. Instead, they're found in these little areas that surround the nucleus. So I've heard a lot of different names for these areas that surround the nucleus. Okay. I've heard them called electron shells. I've heard them called orbital shells. I've heard them called just orbitals. I've heard them called electron orbitals, and all sorts of different things. So don't let that confuse you. Basically, this is the area surrounding the nucleus of an atom where we find the electrons. And the other thing that you should know about these electrons is that they have a negative charge to them. So, we talked about lithium and its atomic number. The number of protons or positive charges in the nucleus is 3. What I want you to notice is it also has 1, 2, 3 electrons. So what we see with atoms is they always have equal numbers of protons, equal numbers of electrons. So there's equal positive charges and negative charges, and that means that an atom overall is going to have a neutral charge. It doesn't have a charge to it in normal circumstances. With an upcoming video, we're going to talk about an exception to that and why we get exceptions to that. But in normal circumstances, again, these atoms do not have a charge because the number of positive protons is going to kind of cancel out, if you will, the number of negative electrons, and there's no charge on the atoms. So I've talked a little bit about the Bohr model, talked a little bit about the protons, the neutrons, the electrons, where each of these are going to go. What I want you to do now is I want you to draw, okay, a Bohr model, or at least attempt it. And I'm going to give you a really simple one to get started with. So let's have you do an atom. Okay. Here's the atomic symbol of the atom. Here's its name. And here's that atomic number. So based on this information that you would get from the periodic table, what I want you to do is go ahead and pause this video and try to come up with a drawing, a Bohr model of a helium atom. So make sure you get the number of protons right in the nucleus, make sure you get the number of electrons right in those orbital shells. We're not going to worry about the neutrons because, again, they're not so important for A and P. So hopefully you paused this video and took a chance at drawing a Bohr model of helium. What I want to do now is kind of review that with you to make sure that we're all on the same page and understanding this. So one of the things that you would have gotten from this little block from the periodic table is that the atomic number of helium is 2. So that means that helium has 2 protons, and those protons should go in the nucleus. And because we know that it has 2 protons, that means it also has 2 electrons. So here's how those electrons would actually be assigned. Both of them are going to go in this first orbital shell that we have here. So we haven't really gotten into orbital shells yet, and we haven't gotten into actually assigning electrons to orbital shells. If you came up with this, that's perfect, that's great. You may have drawn electrons doing something else because you weren't quite sure where in these orbital shells they go. And that's actually what we're going to get into next with our next video, is assigning electrons to orbital shells and how that actually works.